Okay, so if you're unsure like what IEEE Extreme is, give me one moment. There you go. So it's basically a programming competition. It's a 24-hour competition. I know 2 years ago, before the pandemic, it was hosted in, I think it was the Wedge over by the library, because that section is open 24/7. And there's typically an IEEE representative there to kind of supervise everything. You have groups, and you work with those groups to solve a variety of programming problems throughout those 24 hours. It's not a constant 24 hours. You typically have some breaks or get some sleep. It's not like programming 24/7. But like Oz was saying, it's kind of great to test your skills, see kind of like where you are for your own programming experience, things like that. And I believe that there's prizes at the end, I think, depending on where your group places, like how many problems you can solve.
Yeah, you get cash money.
Oh, nice. And then the last thing is there is an IEEE Women in Engineering. If you're not in the engineering part, that's totally fine. They also have the computer science portion as well. It's a leadership summit this 29th. I believe it's all online. And basically what it is, it's hosted by IEEE. There's going to be a bunch of keynote speakers. It's going to be a great opportunity to like network, get caught up on like the latest technology and things like that, anything that IEEE has. And I think that's about it. So today's workshop, it is an introduction to Unity. So get kind of familiar with the creator's environment of that game engine. And then we're also going to make a simple game of Pong so that you'll get used to how to create objects within the editor itself, how to add like hitboxes and things like that. But then also how to program, which for Unity, the main type of program you write scripts is in C#. So any questions?
Where is it? This all online? Do you guys have a website?
Yes. Yeah. If you type in is it CSUSB WiCSE? So I don't know if you want me to write it down. It should bring up our CSUSB website on like the first search result. And on that website, it has a link where you can officially register as a member. And it also has the link to our Discord. So that's all you'll need if you want to just be logged into Discord on your machine, but click the link and then it'll ask you, hey, do you want to join the server? And so that's where we have most of our announcements. So I highly recommend being in that Discord because you'll hear everything about the club that'll be there. Anything else? Okay. Okay. So it is basically like one of the world's largest organizations when it comes to things related to technology. They do a ton of things. Like some stuff that benefits students is like scholarship opportunities, networking opportunities. They hold a bunch of conferences, like the Women in Engineering Leadership Conference. They also have like another one's called like Rising Stars. I think it's in Las Vegas this year, which is a huge thing where they have like tons of networking opportunities, tons of keynote speakers. They also, another like big thing about IEEE is they publish a lot of anything about technology, engineering, and things like that. They also set standards. So in later classes, you might run into some of those IEEE standards. Like in computer architecture, when you get into writing certain things in binary, there is an IEEE like format that you might have to follow. So that's one kind of nice thing, to try to standardize things when it comes to like computer science, engineering, electronics, and things like that. I think what else is there's so many things to it.
Some good examples. So if you ever take hardware descriptive languages like learning FPGA boards, you'll learn System Verilog. System Verilog is a language that deals with synthesizing that, and that is IEEE standard. So they're the ones who make the standard for that. And the most common one that people will probably know is your keyboard. So your keyboard, your A, B, C, all that is mapped to specific numbers. That way, everybody's keyboards can be the same and you can interact with each other. in the same way. That is standardized, the ASCII is standardized by IEEE. So they're the ones who made, the keyboards registered to whatever number they're registered to. And so, yeah, if you were to look up ASCII online, you'll see like the numbers associated with the letters. But yeah, they're the ones who make those kind of standards. So, they're things you use every day that you might not realize.
Same with when you take the ethics senior seminar, you might have an assignment where you have to talk about like a code of ethics. There's kind of two main ones. One is the IEEE code of ethics when it comes to computing, electronics, engineering, and things like that. So throughout your whole college career, you'll probably see IEEE popping up a lot. Anything else? All right. So that's it for our general meeting. So now we can get into our workshop.
I just wanted to say one
Sure.
thing. If you guys do decide to do that IEEE extreme competition, if you saw the newsletter, the code that's used from it, that website is their codes. So those are from past events. So if you want to see how it looks like, what kind of questions you're going to get, because the questions can be very weird. In particular, you have to kind of code and figure out where the mistakes are to realize what they're kind of saying. But also, it's an international competition, and it involves, like USC, Cal Poly, they all compete too. Like all universities can compete. And because it's international, it's from Britain. It actually starts at 5 p.m. Or at least that's how it was last year. I'm assuming it's the same. But it started at 5 p.m. instead of midnight. It's 24 hours. You start off with 3 questions, and then every hour, a new question appears. Now, of course, whoever gets it first gets the full points. And then, the points decrease after that, if people getting it correct. And if you're new, don't be discouraged. It's worth trying, definitely. There's going to be tons of teams that might not even make past like 2 questions. But it's still like really good to just experience. And the teams can only build of 3 people. So 1 to 3 people, of course, but no more than 3. Oh, but they'll have places where you can talk with the other competitors. You just can't ask a direct question like, "Hey, how do you do this?" But if you want to ask a question like, "How do you use an include file for vector again?" Somebody can give something. Okay.
So we exit out of this.
Good news, bad news.
Is it working?
It hasn't passed like the 4th stage.
Okay. Do you want to use mine? Because mine's installed.
It's finished.
It's finished? Yeah, mine is.
Oh wait, that's just.
I have Unity installed, but now I can add a project. So give us one moment to set up a project real quick. So if you want to download Unity, it's free for like students, things like that. Pretty much free for everyone, as long as you're not making money off of it. If you're making money off of it, then you have to buy a license. But if you just want to tinker it with yourself, then it's free.
Well, technically, you can make money up to $10,000.
Oh yeah.
Once it's past $10,000, they collect like a royalty license.
Yeah. So you just type in like Unity download. It'll download a thing. It's called the Unity Hub, which is basically everything you see here. And then from that, they have like community posts and stuff, different tutorials and other projects. They also have, there's like different editions of Unity. So whatever edition you want, especially if there's like a certain feature that's kind of like isolated to a certain version, like an older version, you can install that. And then they have a place for all of your projects where if you already have an existing one, you can add it. Otherwise, you can create a new project. Which I have here. There's a whole bunch of different types that you can do. Your typical 2 ones are the 2D and 3D, but they have some templates like a 2D platformer, karting minigame, and things like that. So let's do 2D. I'm gonna name it Pong. And create. Just have to give it a moment. And then also, let me make sure I share my screen. Screen one. There we go. And real quick, put myself down to disturb. Okay. So it might take a bit because my laptop's not the strongest. So just give it just a moment to open it up. Oh, yeah, you could. Let's do. And just. There you go. All right, and then let me know whenever it's sent, and then I'll see my my mail here. Okay, let's see here. I hope it's okay to go into my Gmail. It should be fine. Just let me know when it's sent.
I think you should.
Should have? Okay. Let's see here. For like the bigger events, so like IEEE stuff. So it's not hosted by us. It's hosted by IEEE. I'm not sure if IEEE Extreme is online. It was last year during COVID and stuff. I'll have to see about that. The leadership conference is online. The IEEE like monthly meeting that's also online. And then come January, like their biggest conference thing, IEEE Rising Stars. It's a hybrid. They have an online. Otherwise, if you want to, you can go in person. It's in Las Vegas. Yeah, that's kind of a big commitment. So it's nice they have a dual option if you want to just like join in online. So most things, as far as we know, for the big kind of events, they typically do have an online option.
And so like the Vegas event, going there can be pretty expensive to get hotels and everything. But if you're an IEEE member, like they can help fund it. So they can drastically help to reduce the cost of going to these conferences. It otherwise might be like $700 or something.
Yeah.
So they may be able to reduce it to like, I don't know, 200. So it's $32. So normally it's more, but if you sign up with a student, the school's registered with IEEE. So as long as you register for a student, it'll be $32.
Yeah, for the club itself, we're not having any membership fees this semester. The only thing that we'll have that'll be like a cost to it is if we decide to do something like t-shirts, we have to pay for that. And also our last two workshops, we're gonna have a circuit workshop and a soldering workshop. And because those require materials, we will have a lab fee for that, but we're gonna try to keep it low. Hopefully under like $10. So that we have the facilities here, basically you're just gonna be paying for the materials itself. Okay, yay. Okay, that looks like it got started. Okay, so are you ready? We got the PowerPoint up. I am sharing my screen still. Oops, that's not it. Okay. And then, so that's the
So we had a bit of a hiccup with this Unity because the schools don't have it right now. I brought my old laptop. It's like 10 years old and it's just way too slow right now. So unfortunately, if we did start, it's going to take a very long time.
So hopefully my laptop will be okay. All right, so let's take over.
Okay. So how to use Unity? Well, let's talk about it. So let's first, just to give a background of what Unity is. So Unity is a game engine. For those who don't know, a game engine is simply something that comes with pre-built materials. So for instance, if you wanted to build a wall, instead of having to put all the mathematics yourself into the code, Unity already comes with that. So it's a bit different. Sorry, I like accidentally clicked on it.
Let's see, plug in the.
Yeah. Well, no, I think I like pushed it by accident. So unlike OpenGL, which deals more with the graphic interface, because Unity does use OpenGL as well, it has a lot more physics and other stuff built into it. So it is a game engine. It came out in 2005, and it originally came out as an Apple exclusive to help them get into the game market. But as you know, they kind of separated and went their own way. So other game engines that are out there, there's like CryEngine, there's Unreal Engine, which is probably the biggest one. And interesting enough, Unity, when it came out, after it separated with Apple, it was a free software service. So it became free for people to use with that cap of the $10,000. And if you're using it free, you do have to show their logo at the end of like building something. And you can use it to build apps, not just games. And they moved much more into the virtual reality, augmented reality space. So it does come with a lot of pre-built features for that kind of thing. So if later in any projects, if you guys do the engineering class, the 455, if you haven't done that already, Unity's makes things a lot easier to build certain projects. So it does have a base code built on C++. But you don't have access to that stuff. That's a lot of the runtime stuff that it uses to be able to do things properly, especially once virtual reality came in. But it's mostly built on C# and also JavaScript for web development stuff. But it's mainly built on C#. So if you don't know what C# is, because this school doesn't have any classes for C#, right? Yeah. Some quick history on C#. So as you might know, C++ came out, way back in the 80s. And then Java came out. Java started taking the market, especially with web development, and it was vastly like outgrowing other languages. And one of the things Java is it is a runtime compiler. So its compiler, does a whole bunch of stuff. It's called a just-in-time compiler. And also Java is an interface. So essentially, how far are you guys on the programming level? So the general classes, right? Okay, cool. So classes. Essentially, Java is just one big class. Everything's an interface, inheritance sequence inside of it, right? So that's how Java was built. It was built that way to make things easier for people who wanted to program. C# was was their way of competing against Java. And C# is built in the same kind of manner. It's an event system. So everything in a way is an inheritance. And so when we go into some of the Unity programming, we're going to see that it is an inheritance. And then again, some games, they came out with it, Cuphead, Hearthstone, Ori and the Blind Forest, Hollow Knight, Kerbal Space Program, which is a great physics game, Rust, and then like a ton more. And then how much? It's free, over $10,000. They do collect some like royalty. So if you don't have Unity, and we kind of already went through this process, but you can just go to the Unity store and you'll see a picture right there. They have the personal version and the free, the student version. I have not used the student version. I got it before they offered it. So I'm not entirely sure, how much worth it is, but if you're a student now, I say go for it. And so you can choose what operating system you want to use. It was built for Windows. It was built for Apple. Then it went integrated to Windows. And recently they're integrating it to Linux. All right, so once we have it, is this one?
Yeah.
Okay. So, she kind of went through that process that once we have it, we can create a new project. We can select, first what we're going to want to do is we're going to want to hit install. Because when you first install the hub, which is what it's going to want you to do, you don't have the version engine yet. So these are like 3 different version engines. You're gonna go add and then select which kind you want. And then from there, you're just gonna go back to projects and you're just gonna hit new. You're gonna put where you want to save it and all that. All right, so once you have it selected, you have all the different options. So we're gonna be doing 3D, or I think you selected 2D, right?
Yeah, if that's 3D, you have to.
It's fine. So all the only real difference is that it's predetermining certain things. So I'll show you right now. So right here, your camera is in 2D view, but you can easily go to a 3D view. If you just select right here, it'll go back and forth. But of course, your camera is going to be in a 2D box right now. So you notice it's just a square. But if we were to change it from an orthographic view to a perspective, yeah, if you, sorry.
If that'll make it easier, that's what
Okay.
yeah, it's gotta make it easier. So, let's see here. Yeah, there you go.
There you go. So you'll notice here, then instead of just being a square box where everything that's interacting is into it, you'll notice that it's more like how your eye works, in which, you know, light is spreading out. And so you'll notice from here, the different types. And again, we can change all these things, even if we selected 2D or virtual reality or any of that stuff. The difference is just that it's already like integrating things and taking up memory specifically for virtual reality. But again, presetting stuff. That's all that's really changing. So pretty simple. All right, so let's go over the kind of things that it's going to have. So at the top, you know, we have your basic file. We have our scenes right here. And this scene that it comes with should be a sample scene. Yeah. So if you want, you can just rename it. Or if you wanted to create a new scene. And so let's do a 3D one. And we wanted to create it. I don't know if I should say 1 year. Sorry. I'll just leave it like this. But you'll notice that it's not entitled. It's not saved until you actually go and save your scene. And so be careful about that because you can do like a ton of work and then all of a sudden it's just gone. And you're like, oh no, this is horrible. All right, so editing is just all the things that we can do that are visible to us right here. For our assets, we're going to be using these a lot. Again, these are pre-made things that are associated with Unity's model behavior system. And so we're not going to be doing much today. It's a pretty easy project. But later, if you start using shaders, testing, any of these other stuff, you can either go to assets or you can just do it right here. It should be popping. There you go. So you notice the same things right here when you right click. Okay, our game objects is where we're finding like the squared objects, our circle objects, all that kind of stuff. And that's what we're going to be using to build stuff. Should be fairly simple. Our components here, we're not going to get into any of this today. These are kind of the more advanced stuff. Let's see, it's not here, but we will be going into our project settings today. So we'll talk a bit about our project settings because we're going to be using our input manager here. And so what that is, and I'll explain it a bit once we go to it, but it's like predetermined key buttons. So if you have a controller, you can use this to easily connect to your Switch or Xbox or PlayStation. And then that way it already has the buttons mapped out for you. So you don't have to do it all through code. All right, and so our windows are just all these windows that we see. If I went and accidentally got rid of this game tab, or we can easily go to window and then go to game tab right here. And then we could just drag it up. Boom. And then close that window for now. Also, you can set up however you want. An inspector right here is going to tell you all the information of whatever item you're selecting. So we'll call it game objects. That's another way to reference this. They're all going to have saved keywords. So cameras and lights are a little bit different. So they already have their own saved thing. All right, so for that, that's all we have. So we'll start by building a simple cube. And we're going to do 3D. We can't easily do 2D. We just have to change some direct lines of code that reference it. For the most part, they're going to be pretty similar for what we're doing. And so you'll notice on your cube here, we can rename it. We'll say phone. All right, so we'll just go over here. We're going to be using a tag today. And so all that is if you've ever used like enumerations, it's the same concept. You build your own predetermined data type. And so that way it understands that when you want to reference something by that tag, it'll know that it'll check for the name on the string. And so we also can do that with layers. It's right here, but the layers, we can also choose a layer for it, but it's a little different because the layer actually goes with your actual view. So for instance, if you had a building that was right here and like you had scenes built on the z-axis and like through each thing, you're kind of going through the next axis. You can build them on layers, and that way your camera, whenever it passes that, it just doesn't create it. So that way it's not in your way. If you've ever wondered how like games, when they get into a wall, they don't just automatically have that wall facing them. Well, this is one way to do it. You just build it on layers. And so when that camera goes into it, it determines, you know, what's your position, which layers should be active, what should the camera be able to see. And then for right here, we have our transform. This is just the position of the cube. So we're going to set this to 0, right? Because it's a 2D, we want to make sure that everything's on the same space. We have our cube mesh filter, which is the, you know, the red linings, the mesh that determines the shape. We have the renderer that just renders it for us to view. We have our shadows. We have probes of lights that we can add. They have a bunch of different built-in features that you can use, but today we're not going to be going over any like visual stuff. All right, and then we have our box collider here. This is pretty simple. This just means that within the dimensions of this cube, we have the capability, or the Unity has the capability to understand that it's a physical thing. So when we don't want things to interact, it'll check the spacing for that. And in our collider, we could add physics materials to it, and we will for the ball. We could also change its size. So you'll notice, well, right now positioning, but like if you ever wondered how characters in games don't just go through walls or whatever, they'll actually do this to push the hitbox a little. They'll extend it a little further out, and so that way when you hit the wall, it doesn't look like your character is like directly on top of it. Instead, it recognizes that, oh, it's a little further ahead, I should be a little back. And of course, for the size here, if we just want to increase the hitbox. But don't go negative on those because you can run into some really funky physics problems. All right, so we're going to go ahead and change the dimensions on this a little bit. So for the most part, our screens, we're just going to keep it like this. Let me just make sure my camera's right. For the graphic. That's better. All right, so that's going to be our in-game cube. We're going to create a little more folders here. We're going to create something called a prefab in a bit. And a prefab is pretty simple. It's just the item itself, like a clone. So just think it's a clone of a specific item. So that way, whenever you do something to one item and you have a bunch of things that are exactly the same, you can just put it in the prefab and then utilize that prefab to affect all of them. And we're going to rename that to and we're going to also create a scripts folder. It's always good to be organized. And a material. So for material, right now you'll notice it's just a gray blob. So you can go down here to material. And this is something that you can just change the color to. And so we'll go ahead and make it blue. And now it's blue. Also, I'm going to extend the length a little bit. Okay. And so we'll go ahead and start creating some scripts. So from there, right click, create C# script. Let's rename it player. Let's just open it up. And just give it a second to open. I had some pre-written code to make it faster. All right, so we're going to go ahead and try to make this bigger. And so this is exactly what you're going to start with every time you build it. And so you'll notice that you start off with a class, just like how Java is a class-based system. Everything's inherited. In here, it's going to be inherited from ModelDB. That's Unity's scripting language that they created. It wasn't that great, but you know, it works for what it needs to. And so whenever you want to reference any of the items that we just saw on the screen, you need ModelDB. You can take it out and you can build your own stuff. This is a C# based system. So for example, if I were to write something like debug, I think it needs to be capitalized. Oops. Okay, I think that should be fine. But we have what's called void start. That's a method that's built into Unity. That simply means that once we start the game, after we render all the materials, we'll do whatever the code says. We also have what's called a void await. I don't know why I'm not using the mouse. I forgot I had it. Okay. So we have void await here. And so what void await does is the same as start, except it does it before you render all the materials. And so you're going to want to use await when you need things to not interfere with others. If you want like a single item in it and you're instantiating an item, you're going to want to make sure that you're instantiating it on all await, or that you're checking that there's no other copy of that specific item. So if we were to go back here, you'll notice here that you have a console window that's going to tell you all the information. So any errors you have, it's going to be right here. So I'm pretty sure log needs to be capitalized. I'm really used to like IntelliSense just giving me the option for it. But we'll go with what we got. So right here, you're going to get a ton of messages. So it's always best to just collapse. All that means is that if it's the exact same message, it's only going to show it once instead of multiple times. So we go to debug.log. And so we should see the message pop up on our console window here. Okay, so when we hit start, it'll say it any second.
All right, computer's not the fastest.
No, it's okay. I think it ran. It's just not showing it. And of course it's not showing it because I didn't put the script to anything. I wrote the script, but it's not associated with anything in the game right now. So at no point is it being accessed, right? So if I wanted to, I can go off of play because you can't save things when you're on play mode. Go to player, go to scripts. And so you can either go here and add the script through add component, or you can just drag it. Okay, so now if I hit play, because it's associated with something in the game, it should say hello. And there you go, hello. And so the whole point of me showing that was that Unity has all these debugging script that's native to it. But like I was saying before, with C#, you can still do a console window. Dot window. Oops. Sorry, what happened? Oh yeah, sorry. Got clumsy fingers. Okay, well, I should have hit out of play. We're going to skip it for now because I don't want to search it up. But the way you would naturally interact with your console window and your PC through C#, you'd be able to do it here as well. I don't think I'm that far off of console. I think it's console.write. So just one more try. I don't know if it's supposed to be capped. But anyways, you can interact with your C# as well, even though it's a class for player that's inherited from mono behavior. Mono behavior is inherited from C#. So that's why anything you can interact with C#, you should be able to do fine just here. All right, well, I'm just going to say I don't remember how to do it, and I don't want to look up. Maybe it's supposed to be capitalized. Either way, trust me when I say with C# you can interact with it. All right, so from here, we're going to just do something pretty easy. We're just going to make our little cube move right now. So we're going to make a public float. And normally you wouldn't want to make something that's public because your editor, which is the scene before, is going to be able to see and access it. So normally you want to do everything private, but to make things easier, we're going to make everything public. And it's far easier and it's great for prototyping. And I always tell people that prototyping is a really good thing to use, especially when you're trying to develop a game and you don't know, how everybody is. So all prototyping is very simple. It's not code that's meant to last. It's called rapid prototyping. You're just building something so that designers and other people in the group can see how that its base idea functions. So you want to separate stuff like, for now, we're going to create the little mouse and we're just going to make sure it moves left and right. Right? We're going to give it some speed and then we should be able to change that speed. And if we were to give it to a designer who's making a game, they can start testing the speeds. And then we can go and start working on something else. And then once we have like the groundwork built for it, we can start making like better systems and structures that can actually do the code nice and secure and all that stuff. So we're going to create something just paddle speed. We're going to give it a float of, I don't know what was good. I think it was going really fast because we're going to make the speed based off the clock of your system. So, and of course, if you want to use a float, you do have to make sure that you put the F to, so it knows that it's a float. All right. Besides this, we're going to create a vector. We want to put 3 so that way it knows that it's a 3-dimensional data type. So it's expecting, 3 different values to be posted into its parameters. But for now, we're just setting up a player that is that data type. And then from there, just gonna delete this. So we're gonna call it player's position because it maps the position. And if you ever see vector 4, I used to use vector 4s all the time. I don't know if Unity still supports it because I started back in like 2014. And then I just stopped and moved over to Unreal. And then I felt like I read somewhere that vector 4s weren't available. But if you see it, all it is that it gives 3 dimensionals, and the 4th dimension is for the graphics. So you can do really cool things with the graphics that take way less processing power and memory than other ways you might set it up. But vector 4s are super great for making really intricate things. You have some graphic and then you give it some kind of motion through the other 3 vector positions. So we're going to have a game object here, and that's going to be our player, so that way we can reference it. Oops. And again, we're making it public. Normally you wouldn't want to do that, but we're going to throw like our little cube into our inspector. That way it knows that, hey, that's what we're referencing. And so again, it's just to make things easier. Normally this is not what we're going to do. And so we want to set our player position, which again, vector 3, that's for positioning, equal to our player okay. And so if we were to go back here, it's basically on this side. I'll show you right now what I'm talking about when I say public. Okay. Okay, so you'll see our player script right here. And you'll see player right here. And right now it doesn't have any game object attached. If this was in private, you wouldn't see this at all. And so when we want to reference it ourselves, we can just throw the object in there. And now it knows. Of course, because it's a script attached to the actual player, you can reference yourself directly. You don't actually have to throw it onto a game object. But for now, this is what we'll do. And so our update method is updating every frame. So when we want something to continuously do things, this is where we want to go. We also have what's called a fixed update. Now, a fixed update is built on a time frame different from like your regular computer's frame system. It's built on time. And so we usually use fixed updates for physics type things because it's much more accurate. So we're going to create a float, and we're just going to say that it's equal to let me say for the transform dot position, remember that up here, this is transform. So when we're referencing transform, we're saying that, the physical space of where we're saying that it needs to be. So we're hitting transform, and then we're hitting position, and then we're hitting dot X, meaning that we're affecting that. So right now we're going to capture our X position. It is not throwing it up there. Okay, so, oops. Okay, so in here, what we're saying is that we're creating an X position, right? Just a value to hold a position. We're setting it equal to the transform position that we showed earlier. So in other words, we're starting it off at that position. And what we're doing, and what I said earlier when I was going to talk about the input stuff, where it said input get access horizontal, that's a built-in Unity feature. So again, if we were to come to edit and we go to project settings, you'll see that input.get access is talking about the input manager. And you'll notice this access right here. And then we're talking about this horizontal. And so again, this already has your left and right buttons mapped to going left and right and the values for how it's going based off time. And so you're taking that and you're just multiplying it by the speed that you said you wanted it to go. So in other words, if it's tracking it by time, you're multiplying that time to go even faster. Let's test it out. Did it start? Oh. Oh yeah, it's a no. I rely too much on IntelliSense. And I do get power speed right? Okay. It is still not going. So if I move it a little more back? If I could push it a little more back? Okay, sorry. I'm like tall and
It
it's.
can go like completely like backwards on itself, so push back as much as you need.
Okay, thank you. This should be working. Oh, no, it shouldn't be working. I didn't even finish it at all. Sorry, I got ahead of myself. I'm just saving the X position. That way, when we do change its position, it knows exactly where it's starting from and how fast it should be moving. So now on the next one, we're saying player position that we created earlier, which is a placement for the actual position. And we're going to use new, and we're going to create a new vector, meaning that we're going to change its actual position. And so in new vector, we're actually going to do math F clamp. It needs to be capitalized. No, it does not. Okay, and so math F dot clamp is within their math functions. It simply means that we're going to clamp an object to a certain space or a certain amount of numbers. And so what we're doing is we're going to say, hey, we want to clamp the X position. So whatever position it's at, we want to clamp that. So let's say -3 to 3. So it's taking two values, and because the X position is directly referencing our object's X position, we're going to manipulate it that way. And so next thing we're going to do is we're going to position. We're putting this because we just want to keep our Y position. We're not moving Y, we're only moving X. So you'll notice in a vector 3 again, it's X, Y, and Z. And so again, we're keeping our X within this limit, our y is whatever it was to start with, because we don't want to change it. And then for our z, of course, we want 0. And then the last thing to do is just make sure that we set our actual object's position to the one that we created, our player position. And now it should move. And so, by the way, I think earlier I referenced it differently. Yeah, so earlier I referenced player dot transform position, right? And I put the player cube into that public value. And I mentioned that you don't actually have to do that. You can just reference itself. So again, here you won't see player because it's referencing itself. So it already knows that whatever the script's attached to, that's what you're talking about. Capitalized. And there you go. So just with that, we can just move it left and right. And you'll see right now it doesn't go to the end of the screens, of course, because we had set its transform position to be no bigger than the 3. So you'll see right there, -3, I can't move it any more left. If I were to go to the right 3, I can't move it any further to the right. There's tons of ways that you can do the same exact thing. If you wanted to make 2 empty cubes, you can make 2 empty cubes and then reference this object to say that, hey, our position can't be past this position. It has to be less than this position, and it has to be greater than this position. Because remember, to the right, positive to the left, negative, that's how Unity will handle it. Which is why when I mentioned earlier, like going negative on your hitboxes can mess a lot of things up. All right, so we got a basic position. We can give this to our designers and they can start testing out what's the speed. I'm sure they would want to extend it further to not just be 3, but we're going to just leave it like that for now. And so our next thing we're going to do is we're going to create some more objects. We're going to call these the walls. Or I know we've been saying Pong, but I was making Breakout. So that's what I was planning. If you haven't played that, it's that really old game, just like Pong, where it shoots up and then the ball comes back down. So super simple. We can also make Pong though. With what we have already, we would just need to add the ball and the borders at the end to say when the game's over. All right, so another thing to mention is right now, you'll see that it has arrows. And so that way we can move the object within the screen. If we were to hit the E button, we can now change its rotation, and R, we can now change its scale. W is for the moving arrows. So our position's on Z, we're gonna hit R, and we're just gonna extend it. We're gonna say this is death, or game over. And so we'll create a script with that. That's not what I meant to hit. And we're going to call this death. And so death is going to be pretty simple, but it's going to have an important thing to use. All these are very basic understanding of things that are very simple. It's great to start building your games out this way, but later on, the best thing you're going to want to do is build your own systems. That way you're not using a ton of memory space and everything's going faster. All right, so we actually don't need these. So we're going to do what's called a collision. So again, this method is built into Unity. So we're going to call it void on trigger. It has enter. It has one for enter. It has one for exiting. And then it also has a collision that's determining when you're inside it. There's a collision and there's a trigger for both of them. A trigger needs to be identified as a trigger, and I'll show you that in a bit. And the collision is just whenever you collide it. create another. Oh, I haven't put that in the game. Well, right now, if we wanted to do a tag, we can just hit other dot. Dot tag, yeah. And then how I mentioned before with the tags, we can just reference it this way. So I'm gonna change it on the one I was doing because I wanted to show a bit of like instantiation and a very small bit of like instances. And so let's go make our game manager first. Before we do this, we'll leave it like this. And so whenever you put game manager, you're going to notice that it is a item. Sorry, my brain's out. And the reason is because it already identifies that this needs to be a mono singleton, meaning that there should only be one ever. So it will give you problems if you try to make it more than two. And mono singletons is another thing that maybe we can go over some other time, but you can create your own to make sure that you're not creating an instance of like more than just one item of something. So again, like a player's online, you don't want to have the player show himself up twice. So it's important to check that it is a mono singleton and there's only one of that player. All right, this is going to be a lot. I feel like I should have just copied. Thought this was going to go like way faster. Okay. So first thing, actually, I don't think we'll get to it. So we won't do a scoreboard. But if you wanted to do things that dealt with like texting or textures or other stuff like that, user interface stuff. So Unity comes with a canvas, and you can use that canvas to be like your home screen, where you select buttons and to start getting all that stuff. But you would want to reference it through Unity engine.ui. That way, it knows that you're directly trying to reference all those type of objects. I guess I'll show you Scene Manager because that's pretty simple. And if you ever want to build your scene now, it's important to know what you need to do. Also, again, it's using. Just think of it in C++ how you have include your directive, your pre-built directive that you're trying to access through linking. C++, it's going to be include, and in here it's just using. Same thing. All right, so I'm going to try to cut some things off. Hopefully they don't interact with each other. So I made a public integer called lives. We could just set that equal to, like 15 or something. And so originally the plan was you have 15 lives. Whenever it hits your death zone, it just goes down. Once it's end, it just goes to game over. If we're not doing any of the UI stuff, because I don't think we'll have time, I guess this won't matter as much. You know what? Let me just paste it into here. That way I don't have to keep typing it out. Yeah, hopefully I can get through more like that. Yeah. The site, right?
I think it's on your side.
Okay.
Not on my side.
So we have our game manager copy here. So right now I'm just going to call it's, not actually on Unity, it's on Visual Studio. So it's not like this script is connected. So we got to put it to the one that is connected. Be very careful if you ever do this, that your names are the same. It's a very easy way for like people to mess up. And it could drive you crazy trying to look for a solution of something that, isn't there, or that's so simple. All right, so we're gonna go some of the stuff. We're not gonna do UIs probably. I don't know if I have the time to set up because you do have to move all the pieces into the right place. And I'll throw a few in just to show you guys, but I don't know if we'll have time. All right, so public static game manager instance is an important part to kind of understand what an instance is. So we're making it public so that way all our other scripts have reference to our game manager. So when I said earlier that, the death script, the way I made it was that it can call the instance of that game manager. Essentially what it's doing is that it's contacting the game manager, and in the game manager, you have the value to end the game. It is game over or reset. Technically, check game over just checks if your lives are low enough, and then resets the one that actually resets. And so what death was doing over here, and I guess we can put it in now. It shouldn't work because I think I'm missing some other scripts, but excuse me. And now from here, because it's an instance, because I declared it as the other script.instance, we can now reference any of the files that are in the game manager. So for here, we wanted to enact lost life. And so this way, like, game managers are great to do because picture like old school Mario. Mario's running and there's all these items and an item hits him. Now, it shouldn't be the item telling Mario what he should be doing, right? It should be Mario who understands that, hey, I just got hit. I should kill myself. Horrible thing to say, but that's how it should go. Because imagine putting a script on every single item you got. That means you have a ton of little bullets or other things that can hurt him that are simply trying to, that are being checked every frame, right? It's far easier to give those little bullets a simple script, like an instance that declares them as a bullet. And then Mario, when he gets hit by it, he sees that it's a bullet. He can reference it and then say, what am I supposed to do when I get hit by a bullet? Oh yeah, shrink or die. And so that's why I wanted to show you guys instance. So it's a little more out there, but I think it's something important to know for when you start building like your own type of systems. That idea that taking like an inheritance interface structure with your event system will allow you to like be able to put like a ton of stuff on one script that references, like all your guns and whatever kind of like weapon system you might have, for example, and then deal with it on another script. And it can shorten everything and make things way less complicated, because instead of you going to each gun to see what it's doing, you only go to it to see a value. You would go to the other script that's actually determining what things are happening. And so it's just it's a great way to make clean code. Okay. So from here, I forgot where I was. Oh, so void awake. Remember how I told you that before awake before it renders everything, it does whatever's in the code, where start lets everything get rendered and then it does whatever. So we talked about mono singletons. We want to make sure that there's only one instance of game manager, and this is what this is checking. If there's another instance, another game manager that was created for whatever reason, you wouldn't know why, destroy it, get rid of it. You don't need it. You should only have one. And so it's just a checkup. And so we have our setup right here. So we're going to instantiate our paddle. And so when we instantiate something, dang. So normally if you hover over something, specifically like something that is Unity built, like an instantiation is a method built into Unity, the IntelliSense will like tell you exactly what's supposed to go in it and how many overloads you can do for it and all that kind of good stuff. So in this case, what it would say is it would say that it can take in a game object, it can take in a position or like a vector, vector 3, and then continuing identity is a rotation. So we use quaternions for rotation. That identity just simply means that we want it to be at the same rotation of the clone paddle. And then as game object just means that clone paddle should be a game object. We're setting it to a game object. All right. So void, check game over. So we're not going to set this one up, but essentially what it's doing for the time.timescale, all that's doing is once we die, it's going to wait that amount of time before we actually do the next action, which is to invoke the reset, which is a method over here, and the amount of time we want before it actually takes effect. And so reset delay is set to just one float, so just 1 second. And again, if you ever see like, they should be like yellow, and if you put your mouse over it when you download Unity, and it gives you like a description, you can go into that description and click on the item itself. So if you ever wanted to see any of the actual code that was in Unity that they built, you can just click on it. And that way go to its reference, and then you can see all the different types of overloads that it takes, all the information that you need for it, which I think helps tremendously if you're ever trying to understand what people are doing or how they're using Unity or the things that it has built in. Because, you know, just using it as like a mystery is never a good thing. Okay, so for Lost Life here, we're just destroying this clone paddle. We're invoking a setup paddle. And so again, right here, invoke, we're taking a string of another method, and you'll see it right here. This is the method we're using. And then we're just setting a time before it actually invokes. I think I can set it up real quick just to show you. So that way I can show you guys prefabs and instantiations. That I thought that's commented. I don't know why it's saying that. This is commented out. Anyways. Before I do that, let me put the ball in, because the player and the prefab I had made into one prefab. I didn't click on it twice. Okay, so just to go over what the ball is doing, and we were going to change a few of these things. So like a lot of this I just kind of created today to make sure I can stay on schedule. And so it's going to bounce, but it's not going to bounce vertically. And the way I wanted to show you guys to do that is we can create like 3 objects, and each one affects the ball differently. So we're going to go over rigid bodies a bit. It's a physics component. I'm actually not a fan of using rigid body, especially if you're a beginner. It makes things way easier, sure, But because it's a physics component, there's way more to it and way more that can go wrong. I always prefer to use like WiCSE to determine the space between something and how far it should go from. But on the way, we need to make sure we get the component of the midpoint so that we have reference to it whenever we do any of this stuff. So again, fire one, input, down input, that's from the input manager that I showed you guys earlier. They have a section called fire one that has everything pre-built. And then this is just to make sure that we can launch it once, so it's not moving until we launch it. And then from here is kinematic. What that means is that it can't rotate. If it is kinematic, it can't rotate. And then add force is a unity method. And so you can just add force based on whatever direction you want. So right here on our X and our Y position, at the top, there should be like force of 400 or 600. And then the collision, I don't think I have finished setting that up. So we can either do that now after we see what's up. I have not created the game manager. So what we want to do is we want to make sure we attach the game manager to an object, because remember, it doesn't actually take effect unless it's in the game attached to something. And then we want to create a ball. We're going to do a 3D object, sphere. From here, we're going to move it a bit up. We're going to shrink it a bit. Doesn't need to be that big. Oops. And then we're going to take it and we're going to call what we're going to make it a child of another object. So it's not super easily noticeable from here, but you'll notice it's indented a little bit to the right under player. That's because, and you'll see an arrow on player. That means that it's a child of player and that it can inherit all the stuff that are in player as well. And so the cool thing about that is that whenever I move player, the ball moves along with it. If I were to just move the ball, it's its own separate thing. But if I move player, because it's what we call the parent, all its changes for like transform and all that other stuff affect its child as well. And so in our prefab folder, we go ahead and throw the things in there. Player script. This needs the ball script we created. Okay. Okay, so you'll notice right here that it turned blue. And so when it turns blue like that, that means we do have a prefab. And so this prefab, again, is just a clone. If we were to take it and drag it in, you'll notice that, right, it's the exact same thing we had before with all the same scripts and behaving in the same similar way. And in fact, we'll probably get rid of this because earlier in the code, when we put instantiate just means create. So it's going to create the object without us needing to have it in there. Okay, I have one red line. Oh, so earlier I said that we were referencing the scene. And so that was in Game Manager. And we have right here scene manager.load scene, application.loaded level, meaning that whatever level we're on now, we're going to load that scene. And we're going to load it. We're going to load it whenever the reset is called. But in order for that to work, Unity has to know what scene you're talking about. And in order to do that, you have to go to build settings. And sample scene is in there, but we're not using sample scene. We're using an untitled because we never saved it. File. Is it okay if I save it? Okay. And so we'll save it. We'll go into our scenes folder. We have sample scene there. Call it level 1. All right, so now we have level 1. And what we're going to do from here is an easy drag and drop. We just take level 1, throw it in there. I think it'll go away when I push play, or it won't show back up. Oh. Okay, so in Game Manager right here, I needed to reference, because I had put it public, and because I was saying that it needed, that it was public, and that all its dimensions and other like info was going to come from that object. We need to actually drag it over. So we had already made it a prefab, and we're just going to drag and drop. Another thing to note, that you can lock your screen right here. So if you have like multiple items that you need to drag, right, you can lock your screen, and that way you drag it over. Otherwise, it's going to go until those items that you had selected. So if you don't want the inspector to change, you can just do that. And it says it wants a brick, so give me 1 second. I think that's fine. We can drag our brick into. And it might freak out that there's no text, but I'll just comment it out if it doesn't let us do it. How does it start? Oh, there it goes. So you should notice that once I hit the mouse key, because fire 1 means your mouse shoot, it did not do what it should do. Oh, I need a rigid body, that's right. Okay, so like I said earlier, rigid bodies were for physics, and we're using a physics component. Right. So we can go to ball, we can see our prefabs from here. And so from here, we can go to add component, and we're just going to add a rigid body. Okay. All right, so for rigid body, we don't want to use gravity. We can totally work with gravity. It's going to be more harder for our project for what we're doing, so we don't want to use that. Mass 1 should be fine. Another thing that we're going to do is we're going to throw in some physics for it. This comes pre-created. So let's go to materials, and we'll create it here. Physics material. We'll call it bounce. Okay, and we'll take that bounce, and you'll see that it has right here some dimensions, because we want the ball to just be going everywhere. You know, we're going to take out any kind of friction, and we're going to say that we want that maximum bounce coming from it. And then from there, we're just going to select our ball, and we're going to have in our sphere collider, we're going to have this right here that says material. Now, right now it says there's nothing, but we can select, and you'll see the created physics material for it. We can double click that, and now it has a physics material ball to it. And so I think it has everything. It has the rigid body. Right here, constraints, we can freeze, like if we don't want it to move a certain direction. So Z would be a great example here, because we don't want it going back and forth. We want it exactly on 0 because we're creating a 3D object, and we're trying to treat it as a 2D. And then again, is kinematic just means it's not rotating. So let's go ahead and hit play. And there it goes. And then it goes off forever because there's only one brick and it didn't hit it at all. So we'll go ahead. Thank you. We'll go ahead and duplicate our brick. Again, that was the great thing about prefabs, is that we can take this object right here, throw it in. Now we have a brick we can just throw everywhere. I didn't add the brick script, so we'll do that in a bit. Let me just make some duplicates. So if you hit like Control D, you can just make a duplicate. And if you ever happen to hit Control and you move it, it does it. It snaps to a specific position. That way, if you want it to be more accurate in how far you're moving, you can just hit Control and then move it. Oops. That should be fine. Let me throw some walls in here. And again, the way it's built right now, it's just checking that there's a box collider, right? There's nothing specific because the bricks don't have a script. It's not going to destroy them. It's just going to bounce off of them. And then we'll put the script and it'll destroy. Technically, it'll keep count. We just won't be displaying it. And we'll rotate it 90 degrees. Be careful, of course, whenever you just rotate something like that, because now its Y position is its X position. So if you try to change it later and forget, it's just an easy mess up. All right. I should have checked if they're on Z. Well, let's find out. It's it's right there. Okay, so just bring this down. Let's create the brick script before we solve that other thing. That way we should be able to see what happens to the bricks. That's, yeah, that's, I hit Control C. The other thing we got to change is that this was called bricks. The one belonging to Unity was called bricks. So if you don't change that, it's not going to understand. It's not going to have a link to it. So this should be able to reference the other thing too. So we'll put that as well. So the only problem that is getting stuck. Huh?
Like, because it seems like it's not bouncing back.
Yeah, with the bounce physics, it should be doing it. And I don't think I called it to anything. Uh, Hmm?
Is it because bounciness is zero?
yes, that is completely accurate. I did not change that. Let's set it to 1. Now it should bounce. That makes so much sense. I just saw the other two and I saw 0 and I was like, oh, it's fine. I needed to change those. There you go. And so it's destroying itself from here. And so you'll notice this, that it gets stuck. And so one of the ways that I was going to go from it from here is we can create multiple objects and we can decide when it's colliding onto these objects and what we want to do. So essentially, was it? No, it's not ball. So this part that I had commented out right here. Okay, so this is on collision. Again, this is another method in Unity. Collision, other, you can call it, of course, whatever you want, but that way you're able to reference here. So it's saying if other.collide dot tag, so we're looking for a tag specifically with this string wall. And so if we go to the items, and just a bit. So we can select that item and you'll see tags right here. And so you'll notice, of course, we don't have that tag. We can add a tag. And we have to make sure that we're spelling it exactly the same. I don't know if that was it, but we can double check. Well, all right, cool. All right, so now that we've added wall, we actually have to go to the items and like tag them as well. And so now they're all tagged wall. And so all this is doing is that when it's on a collider, and again, I put hello here, and debugging stuff is always great when you want to make sure it works, that it actually runs through it. And then we're using this add force again, and we're applying 2 to the X position, and 100 going up. Or technically, it's going from whatever position was last left. Okay, that's how the add force is going to work. So I don't know if that's enough to make it not go back and forth, but hopefully it is. Oh my, I can't go further than that. Oh, it's going up because I didn't set it to root. And so it's not going to end because I should bring this a little more up. We can take all these, duplicate them, Control D, bring them down a bit, Control D, bring them down again. And you know what? So for testing purposes, it's always great to leave things as public. And we're going to see that with our prefab ball right here. We're going to go to the prefab. We're going to click the ball. And again, you can't see the distance the clamps are at. But if we were to go to it, right now it's just hard-coded and we don't want that. So we can create two public values. We'll call it, just B. I'm super horrible with names. Let's say -5, BB, 5. And they need Fs. And proper spelling. Cool. And so we need to change these. I could have just left it at one letter and do the negative. We'll say B. And over here, we're going to say BB. And so on your player, you should see it pop up now. It's public. So now you can see it on your inspector, which is cool. But if somebody else is using your tools or using your game or trying to help you develop something, that means they can see it too. That's why we don't like using public. We don't want people messing with stuff they shouldn't be messing with. And if they can easily reference it, they're probably going to mess with it. Player, see, you'll see right here, B, BB. And you'll see these little arrows to the side when you get right here. That's because now you can adjust it all you want. And so we'll leave it at there. All right, so the only thing that's not working is the collider because it's supposed to be a trigger. And I did mention that, but we did not set it as a trigger. Done. Okay, so this script was calling it a trigger on trigger enter, which is going to be different from collider. We can still use collider as a data type, but this method on trigger enter means that we need to actually reference the object as a trigger. And you'll notice it on its box collider right here. There's a thing that says is trigger. You just check it. And now if it hits it, we should die. And so you'll notice we disappear. That's our way of dying. It's still not long enough to go to the end. And so, yeah, I guess we'll leave it at there. There's still some things for timing. Scores. Let me just show you really quick, scores. Okay, so go to game object, go to UI, and you're gonna see all these things here. So if you want like a full screen thing, you're gonna go to canvas. And so canvas, whatever's in your scene view, of course, is what you can deal with in your game view, is how the player's gonna see it. So your canvas, you'll notice it's not the whole thing, but it is on your game view. So there is ways to change that, but for the most part, it's gonna take like the whole screen. So it doesn't adjust in size, right? Like we can adjust in size, it's not gonna change it. And in canvas, we can put another UI text. And you'll see it right here on the game screen. And then over here to the right, this is where we actually change what we wanted to say. And so we can change the colors too, and we can change the size. We can do it the same way we do with other objects. But remember, if we're doing this, we're actually changing the box. We're not changing the text size. If we wanted to change the text size, we'll go right here. Font size, font style. Unity didn't used to have this Pro text mesh. It used to be something that you would download separately. And I guess they liked it so much that they just included it for everything. But this one's like way more textiles, way more colors and patterns and other things you can do with it. But it can lead to some more problems. So just be aware of that. And so if we were to include a button, whoops, go down here. Okay, so we have a button. You'll notice that it also has a text. We can click the text again, rewrite it or whatever. It's a child of the button. The button's the parent. And so if we wanted to add things to the button, you see an on-click command here. You can just hit plus. And so you would drag your script to that. And so an easy one to do should be our death script. So we'll drag it into here, and then we can see the methods. Huh? Sorry, say that again?
Is because the map is not public, that's not showing up, or?
Oh, possibly, yeah. It does have to be public, and death is where we inherited it, not where we had the reset. The reset was in Game Manager. So I could throw Game Manager in here then. Oops. Let's see if we made it public. Okay, so we didn't make it public the way we wanted to. So by nature, whenever you put void, it's going to be private. You need to make sure you're setting it up public so you can have access. It has UI, so. I don't know, honestly. It should easily be that simple. Like I've made buttons plenty of times before, and I might just be missing one reference thing that you have to do at the top. I'm pretty sure you just have to have the using for the UI, so that way it understands what a button is. And that way it can see all your functions that you've created. And there should be a list when you go to that, after you drag it in. Yeah, there should be a list once you just drag it in here. So, oh, I got it wrong. It's the object you need to drag. So Game Manager should have all that stuff. So you drag in the object, not the script. And there you go. So now you have it. So it's going to come with a ton of functions of its own that are inherited through model behavior. So some of these you'll notice that, oh, I didn't create them. Why are they here? Well, it's because model behavior has that and it's inheriting those functions from it. Oh, there it is. Reset. Okay. And so, yeah, so if I hit play and I hit that button, you'll notice it just resets. It loads the level. And so it went out of color. And that has to do with materials, because this is considered like a whole new scene, a clone, like a prefab. And so the materials wasn't dragged over, and so you want to make sure that you're dragging it over. That's why model singletons are great, right? Because when you redevelop the scene again, you can end up with the same character. So I forgot what I said before, but model singletons, I don't know if I said, sorry, I'm tired. But yeah, that's why model singletons are great. And so I mean, we'll leave it there. There's so much you can do. There's so many apps you can make. If you guys haven't taken 455, try to learn this thing. It makes everything so much easier. And also try to learn it just so that you can, build up your resume, because people are going to look at that. I applied for a Google internship, and they want links, right? Either to your LinkedIn, so make a LinkedIn, because it has that directly there. I've already seen that for Google, for AT&T, and for General Motors. They have a section directly for LinkedIn. You don't get to switch it or whatever. You cannot put anything into it, so you don't have to add a URL to it. But still, it wants a LinkedIn account. And then after that, you can put your own website too. They'll ask for your own website. And at the moment, I'm trying to develop my own 3 website where you can I'm trying to make it visually look like you're inside my head. So kind of weird and fuzzy or whatever, but you're going around and you're seeing the things I've built. So you're just a character that's walking around. And it's an HTML build with CSS, JavaScript, and HTML. And it just calls references to certain videos. And so I'm trying to make it look like you're inside my head and you're just walking around. And then you go up to some TV screen, and then it starts to play something that I've done. And on the side it has letters and other stuff about what it is and describing it. So yeah. Sorry, midterm week. I was tired, guys. I'll put stop share.
Let's say any questions at all? I know it's kind
Oh,
of a
yeah.
lot, but
I'm sorry, I didn't ask questions at all. I'm sorry, guys. It's like I was going too fast.
otherwise, yeah, you can stop.